Okay, so I'm going to talk you through the review here quick and see if we can put this together. So the first one here, you have triangle ABC. They tell you A is 39, B is 106, and C has a length of 78. So if I was doing this, the first thing I would do is I would draw my picture here, okay? So if I draw the picture, ABC here, okay, I would fill in the 39, the 106, and the 78. And how do I know that? Based on big letters or angles, little letters or sides opposite. Now, easiest thing I want to do is law of sines if I can. So the first thing I'm going to do is I can find 35 by doing triangle sum theorem. Once I find that, I can do law of sines using this and the other ratios. Okay, so if I would do sine of 35 over 78 equals sine of 39, right, over little a, I could find little a here. Okay, now once I find that, you could do the same thing then for b, right? So what you could do then is you could take sine of 35 over 78, right, would equal sine of 106, I'm running room there, 106 over little b. You can do the cross you know, divide by the cross you don't know, and that would complete the cycle then for that, okay? For number 2, you have 3 sides. So again, I would kind of draw the triangle if you want, right? And when I plug them in here, then I would have 9, 7, and 15, right? And then if I would go through here, the first thing I do is find one angle. So if we go through and find letter C, there is a formula in your sheet that does this. Otherwise, you can do law of cosines. So we do it. If I do that right, I'm going to get 139 degrees. Okay, now once I get that, I can do law of sines, right? Because now I know this relationship right here. I could write that like this, okay, and then relate it, maybe find b first. So what you do is you do the cross you know, divided by the cross you don't know, take inverse sine, and now we get something close to 18 degrees. How do you find the last one? Well, I don't have to do very much, because if I know 2, I can just do triangle sum theorem to find the last one. All right, number 3, 3 sides, or I'm sorry, side angle side if you draw it. So if you can't see that from the picture, that's what I would do. A is 76, right? Little b is 6.2, and this is 9.5. So this one's a little bit easier because to find A, it's just a calculator problem. So what you're going to do is put all this in your calculator. That's going to give me A is 10. Once I get A is 10, what can I do? I can link these two together here, okay, and use law of sines. And what do? You set this up here. I would do the cross you know, divide by the cross you don't know, and then take the inverse sine, and it would give me something close to 37 degrees. So then the question is, how do you get this last one? Again, if I know 2 out of 3 degrees, I just subtract from 180. Okay, so we're skipping those. All right, this one's a little tricky. I'm starting my video over because this answer's wrong. So I have a pole here where it's 8 degrees here. So, and then it also says the shadow's 25 feet. So if it says here this is 8 degrees, do you see how I got 82 degrees for that? And then it says this angle down here is 48 degrees. So again, similar problem. What I have is I have 2 angles. I can find the third. This turns out up here to be 50. Why is that important? Because then I know this relationship. So I can do sine of 50 over 25. And then what I want to know is the length of the pole. So I'm going to take sine of 48 over x. I'm going to do the cross I know, divide by the cross I don't know, right, and get that length. Okay, so if I did that quick, actually I had to change that. So sine of 48 times 25 divided by sine of 50, you're going to get something like 24.25. Okay, now on the test, we'll make sure we diagram the picture for you, but a little better. That one didn't work out real great. Okay, number 7, J.P. Miller hit an iron 14 degrees on a line between the hole that is 310 yards away. Okay, so let me diagram this for you. And how far is the ball from the hole if it landed over here? Okay, this is another side angle side problem, which should be kind of a winner because it just goes right into the law of cosines. Just a reminder that the 2 key points are the 14 degrees and the D that I'm trying to find, right? So this one and this one have a special place. The rest goes in. I can trust you put that in your calculator, and that's what you could get. All right, number 8, let's find the magnitude of a vector. Do you remember that this right here has a version of 1? This one here has a version of 3, okay? So how do you do it? You do Pythagorean theorem, okay? So however you want to do it, because it gets, I think really this could be -1 squared if we wanted to. But -1 squared is 1, 3 squared is 9, you get the square root of 10. The magnitude of the vector would be that, because what would this vector look like, right? It would go 1, and then 3. The vector would look like this. So again, if you wanted to sketch it, it's a pretty ugly picture, but 1 and 3. Remember, magnitude is always positive. Now, the next one here, if I give this to you in component form, if you're going to subtract 2 vectors, and this is multiplied by 2, and I give you these, okay? You could write it in component form if you want, however you want to put it together. But I'm going to take a version of 8 and negative 3, which comes from here and here. And then 2 times that means I take 2 times 5 and 2 times 9. Okay, so one way to do that, these components then become negative 10 and negative 18. Compared with these two, how do you find this? You take 8 plus a negative 10, and you get that, right? Because I've already taken care of the negative here. And then negative 3 and negative 8 would give me negative 21. Now, that's not the only way to do it, okay? But that's one way to do it. So the answer, either that or that, same form. How do we do unit vector? Unit vector is a combination of the two. So to do unit vector, what you need to do is you need to find the magnitude first. So how do we do that? You take some version of 3 squared, some version of 3 squared, negative 3 squared if you want, 2 squared, right? And I'm going to get 13. So how do you find the unit vector then? It's basically each component divided by the square root of 13. So when you write it in component form, it's going to be negative 3 over the square root of 13, 2 over the square root of 13. We could rationalize it, but we'll just leave it. Okay, next one says, write vector v if it has a magnitude of 7. So this time they give you the magnitude of 7. Okay, and has a direction angle of 60. How do we break it into its pieces? Now, this right here then is 60-degree angle. Okay, there's 2 ways to look at this. 60 degrees, where's the magnitude always? It's going to be here. And what I want to basically find is x and y. Now, there's a formula in your reference sheet that gives you this. You're welcome to do it. I would like you to know to find this. It's just cosine. So you could do SOHCAHTOA and get that, and this is just sine. But if you want to use this formula, that's how it's related. If you do it carefully, they got exact answers. I will take decimal answers on the test. This is the version you would get. Okay. Number 12, to slide a storage box across a loading dock with a force of 40 pounds at an angle of 26 degrees. So if we draw our little box here like this, okay, so I have a box here. It's 26 degrees. This is 26 degrees here. Okay, how much work needs to be done to have it drug up the thing? Now, we're not going to ask you necessarily to calculate the work, okay? But what we could be able to do here is if this is set, we'd have this, and we have this, and we have this, okay? So depending on, and it's 95 feet across the thing. So the part of this that's the work equation is 95, because I don't know if you know it's force times distance. But what do I need to know, just to emphasize our part of the problem, is down here, that part of it. So I don't know if you can see it or not, but the angle, the 26, is created then to overcome that, and it would be a version of cosine. And now that I look at that, except for component forces, we're just going to leave that one kind of off, because I don't need you to know the work formula for that. But again, cosine related to where it is. Okay. So a pretty quick video, sorry for the rushed nature of it, but again, you can rewind it and look at whatever you need. I think fairly straightforward, represents the